Year is it? How many horsepower? All that. How much PSI?
1911. 65 horsepower. Right now it's carrying 125 PSI.
Okay.
Rated, the boiler is rated 140. Okay. I carry 125. But I am legal at 140.
So do you just keep it at 125 just for safety? Because that's all you need it for?
Plenty steam for what we do here.
Very cool.
So
how does it work?
Well, initially, if you want to start from the beginning, so what happens is we put the steam engines away, and now it's time for the showtime. So showtime starts out by, we would put, obviously, the plugs in the engine so the water doesn't run out, because at the end of every show we have to drain the boilers, because obviously when you live in Pennsylvania it will go below freezing, and anything that goes below freezing will bust and break, as we seen the other day with the Lancaster engine fiasco with the valves and everything that were traced. Okay, so, and that's what happens. So you have to drain them, you got to get the water out of them. So obviously now they're an open shell waiting for water. So when it's time to go put water in, that is what's called a hand hole, okay? And those were designed so you can see in. It's an oval shaped hole, about 4.5 inches by 2.5 inches, where you can see in. You can get something. You can get scale out if there's scale in there from rust or whatnot. This particular engine has 3 this size and 2 smaller ones that are really hard to see on the bottom of the barrel at the back underneath the ash pan door. Okay. That's what a Frick has. So you will put those 3 plugs in, all the plugs in. Another one of the plugs is up in the smoke box. That's number 2 of the big ones. Okay. And then you would have number 3. The third one is above the smoke box door. You can see that there with the gold washer. Mm-hmm. So those 3 are in. This one here we leave out. That's where I put the water in it. Okay. So you put water in it. You fill it with water. Okay. Now it's full of water. And we put boiler treatment in it, and then you put that plug in. Okay. Right now, the boiler is sealed, and theoretically, you could build a fire and start making steam pressure. Okay. So now we're at that stage. So we are now building. We have our first fire in. We're making sure that all the leaks, there's no leaks or anything. This is the steam ejector line for the injecting of water. This is a water line. So what happens here is, once you have enough steam into this dome, here's where 99% of your steam is going to be housed in this dome right here. On the top of the steam dome, you have your valve, which is the primary steam for the engine. Before we go there, then you have engines for whistles or whatnot, and you have a little one for the blower. What the blower does is it's a nipple pointing up the stack, so when you want to make steam quicker, you can open the blower on the platform, and what it does is it creates a draft. Almost like you're standing back there blowing on a fire, your campfire, to make it burn hotter. That's what's happening. Okay. So you would turn that valve on. What it does, it will supply steam to the back of the engine where the injectors take place. And this is a water line. So what's going on is steam's going back, and eventually through the ejector system, which we will get to, it pushes water back up through here. This is a check valve. What this check valve does is allow nothing to go this way. In other words, this valve's open. The steam is sitting right here, because that's where it stops. What's going to happen is the water under its own pressure is going to be pushed. This has a flapper. The flapper will open, the water will go through and go into the boiler. Whenever I turn it off, the flapper will close. That keeps everything up here. It's a check valve, like a one-way gate. You can go in, but you can't get like a Chinese finger lock. It won't come out. So there's one on both sides. We'll walk around the other side. Obviously, same thing. It's the same principle. It's just 2 injectors on the back of the engine. Our Pennsylvania and most the NBIC requires that we have 2 ways to put water in a boiler. I have 2. Some engines use pumps. Okay, so now we're all up and running. We're getting steam pressure now. We're up to 100 pounds and blah, 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 blah. Obviously, you do the oiling of all the mechanics. You make sure everything, there's a lot of moving parts. The valve on top, on the very top, the big valve, that is what is called the steam line. So what that is, this maroon pipe right here, when you open that, it will bring steam, okay, to the throttle valve, which is the next valve. Obviously, the throttle valve is closed right now, okay? When it's time for you to go, let's say you're ready to go, you're all watered up, fired up, greased up, oiled up. When you open the throttle, what happens is the steam comes through here, down here, through the governor system. There's a valve in here. It's a two-seated valve that goes up and down, and then the steam will go through there into the valve chest. This is the valve chest right here, where the steam goes here, 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 and it has an exhaust. So it's piston back and forth, piston, steam in, steam out, steam in, steam out the exhaust, up the stack. As the governor balls spin, what they do right now, that valve is sitting wide open. So when you open the throttle, all the steam's going to start coming through, and as that spins faster, because your engine starts to speed up, this valve will start. There's a rod. Those balls will open up, and that stem will come down and close this valve off. So now it's going to start limiting your speed at a speed that you have set. So what happens is if you're on a pool, you're pulling and it's like, oh, say I'm under a load, I'm starting to slow down. Well, once it starts to slow down, you don't have to touch the throttle because it has a governor system. When the ball starts spinning slower, the valve starts opening up on its own, allowing more steam to come in. So that's like the governor. It'll help stay. So you don't want to be in a sawmill trying to work your throttle back and forth to keep your speed. The engine does it for you. They were very smart back in the day how to design it.
So that's
good.
Without saying it's automation, that's like the only level of like operation that you're not manually doing every time.
Correct.
Okay.
It is adjusting your speed. No, obviously you can shut the speed down yourself by cutting the throttle down by yourself. But once you get on like a sawmill or whatever you're doing, and they want you to run your engine 240 RPMs or 250 RPMs to make the sawmill run 500 RPMs, you get that set. This is a ball ranger governor. You can set the speed at that. Now what's going to happen is your throttle's where you want it, the steam's where you want it, you're 250. So what happens if he saws into a piece of wood, well, naturally it's taking more horsepower because now he's cutting into, when it's slowing down, that will open up on its own and allow more steam to come in, and the engine will go, gotta go faster. Whenever let's say the saw gets through the piece of wood, and it'll actually die back down to normal speed. It just controls the engine speed. It is controlling the speed, but what it's doing really is controlling the steam flow into the valve chest.
Okay.
And obviously, like a vehicle, this is an external combustion engine where your car is an internal combustion engine. The piston, the crank rod is there, and then you have the connecting rod that goes into the piston. And then, of course, this would be your crankshaft, like on your vehicle, which is connected to the flywheel and this pulley over here, which controls your governor. So back here is where it's taking its read from back here. So when this is spinning, it's spinning the governor. Belt would fly off, that pulley would drop and kill the governor. Okay, so it would shut the engine off, so it wouldn't go a million time revolutions a minute, blow up. Okay. Just the engine would fly to pieces. That saves it. So let's say you fell off the platform and the governor belt fell off, it would run away from itself because it has no reason to slow down. It'll just run to it. Pieces would fly. The governor would trip and it would shut the engine down. It's a safety feature.
So is that an extra fail safe that not every engine has that, do they?
Yeah, they're supposed to.
Okay.
Yeah. But they're supposed to. That's basically it. And on a traction engine, you have your forward and reverse, and with an eccentric, which redirections the valve as to spinning, how it spins the crankshaft, clockwise or counterclockwise. You redirect it to go forward and reverse. And this was a 1911 build, and the one engine would be sitting right here will be a 1912 build. Frick changed their reverse. The next year, it's a different reverse. They improved it like everything else, Oh, I got to do something better. So that is the basics of a steam engine. Of course, when the show's over, you have to cool it, take it down, drain all the water out of it, and then we put them to bed for the winter.
Do you have to rinse out like the old water?
We once all the water is out, Monday in 2 days from now, we will pull them over here on the grass where we get underneath them with a fire hose and pressure, and we'll flush out if any scale has developed. So we like to keep them as clean as we possibly can. We try and take really good care of our boilers because they need to last. This one here is original, and it's, knock on wood, I'm very blessed to have a boiler that's still in the shape that it's in. I only ever put tubes in it in 1986. Now I know that I'll have to eventually attack that project. I will, but so far so good.
Very cool. What's your favorite part of the engine?
The engine. There's no favorite part. It's just being able to be part of a group of people that own history is my favorite part of it. And being this part of the year is extremely special to me. I grew up right across the road, and I've been doing this for 50-some years over here. It's just extremely good time of my life. So, the engine is the most special part of the engine. Just being itself.
Mm-hmm. Very cool.